Very good afternoon, sweetie ma'am. This is Professor Gupta.
Good afternoon, sir.
Right, we have a strong bonhomie from Vietnam conference. I'm very keen to Vijay Singh Rathorji, that is the convener. We are almost 1.5 decade old friend. Yeah, sweetie ma'am.
Yes, sir.
Very good, very good afternoon.
Good afternoon, sir.
Acha, here are my two scholars. One is PhD and PG. They will present the three papers in which my name is written.
Yes, sir. Yes, sir. I saw.
220, 221, and 222. Kindly take care. They both of them are here.
Yes, sir. Ma'am, shall we start the session? Good morning, good afternoon, and good evening to everyone joining us from different parts of the world. A very warm welcome to day one of the 5th International Conference on Universal Threats in Expert Applications and Solutions, or as we fondly call it, UNI-TEAS 2026. I'm Sweetie Sagar, and it's an absolute pleasure to moderate today's online session. This prestigious conference is being organized by Shree KKarni Universe College, Apex University, and Panipat Institute of Engineering and Technology, managed by KK Consultancy Services India and supported by University of Rajasthan, ACM Jaipur chapter, All India Council for Technical Education, and Computer Society of India Jaipur chapter. This year, we received an overwhelming response with over 300 paper submissions from across the globe. After filtering out AI generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by Springer Nature. The first half of the day one of the conference, that is today, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity offline in Jaipur. As we step into the latter half of the day, we carry forward that same enthusiasm, ready to dive deeper into thought provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I am pleased to introduce our session chairs for this segment, Mr. Mahipal Singh Deora, sir, who is an associate professor at Bhupal Nobles University, Udaipur, Ms. Shikha Maheshwari, ma'am, serving as an associate professor at Mahipal University, Jaipur, Mr. Kapil Joshi, sir, who is an associate professor at Uttranchal University, Dehradun. Before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. Each presenter has 10 minutes to present. Please stay within the time limit. Briefly cover your research context, methodology, objectives, key findings, and conclusion. A short Q&A may follow your talk of 1 to 2 minutes. Keep responses brief and focused. Keep your mic muted when not speaking. Stay for the full session to support the fellow presenters. With the kind permission of our session chairs, we shall now proceed with the paper presentations. I would like to call I would like to invite our first presenter for the day, presenting the paper titled Relaxation Redefined, Machine Learning Enhanced Separation of Instrumental Audio for Well-Being under the code 220. I request Ms. Parumita Das to kindly take the virtual stage and begin their presentation. Over to you.
Okay, thank you, ma'am. Am I audible?
Yes, you're audible, ma'am.
Okay, ma'am. Good afternoon, one and all present here. So just let me share my screen, then I will start. Is it visible?
Yes, ma'am, it's visible.
Shall I start, ma'am?
Yes, ma'am.
Okay, so good afternoon, one and all present here. So today I am here to represent my research, that is relaxation redefined, machine learning enhanced separation of instrumental audio for well-being. My paper ID is 220 and I am working under the guidance of Dr. Somshubra Gupta and Dr. Vishwarup Niyogi. Okay. So next is what is the motivation of my work? So actually, when we are very much stressed, incredibly stressed, and we want to select our own preferable music, sometimes we can find that the music is there with very fine melody of piano, but buried with some drum beats which can affect our heartbeat. Okay, so in this situation we are totally stuck and unbake, we are not able to bake the cake. So here my research start. In this research, I want to represent a surgical separation technique where we only focus the parts of the audio stem we like, and we want to filtering, we are able to filtering the part of the music that we don't like, that the sonic clutter. So with the help of machine learning technique, we are just trying to make a, or we are trying to choose those audio streams from a instrumental audio or from a song that actually uplift our moment, our uplift, and it helps us in therapeutic or clinical applications. Next is, here are some literature review that we are going to present, that in traditional method, actually this type of audio separation technique starts with the Fourier transform and blind source separation. But the limitations are there. They are easily affected by the artifacts. Artifacts means the noise, the distortion, and the unwanted things, that the unwanted traits or characteristics are there inside the music, which can easily affect our well-being or our concentration. Next comes the deep learning shift, which is the CNN and RNNs, which revolutionize the music information retrieval. Now, my objective is to and what are the gap? The gap, actually we concentrated on the ratio of the SDR, that is a signal to distortion ratio and a signal to information ratio. But unfortunately, we can't conclude that if the signal to distortion ratio is high, that means it is appropriate for my well-being. Okay, so my research actually try to influence this, try to introduce actually the well-being oriented audio separation, which not only depends upon the ratio of the SDR and SIR, but it actually involves the emotional well-being of a particular human being who have chosen the music for uplifting his or her mental state. Next is the methodology. Lot many datas are available, but since I am working with the Indian classical music and mostly the Indian music, so I have chosen my custom ground truth repository, and there are some condition. Actually, I prefer to choose the music which is rich of the harmonic structure, temporal coherence, and timbral balance. That means which actually used to the high frequency characteristics, which actually used to uplift our or to change our mental state. Next is, this is my architecture. So here we have used the hybrid domain processing. So here, what is the function? When at the input, we are just going to take a signal which contain the time domain information, that is the phase, the continuity of the signal, as well as the frequency domain information, the high frequency parts, that is the vibrato, the formants, which actually define our voice. Not our voice, actually the singer's voice quality or the attributes of the singer voice. Then we have used a UNet backbone. This UNet backbone contain encoder and decoder. As we all know that a song is rich of different types of information, and with the help of encoder, we actually compress the audio into a Latin representation capturing the high level music features, which actually help us to determining the vocal quality. Next is decoder. Decoder actually reconstruct the targeted instrumental stem from the latent space, and this keeps connection actually helps to transfer the high frequency details from the encoder to the decoder, so that whatever audio to reconstruct, that can easily reconstruct it for our well-being only. Next is, I have modified the previous structure, some extra layer. First one is a
Kindly mute your mic.
okay. So the transformer layer we have implemented. Now, what is the function of this transformer layer? Look, if we want to use a song as a therapeutic as a therapeutic purpose, most of the time we can see that this slow and rhythmic music will help us for the therapeutic purpose. So with the help of the transformer layer, we actually including the rhythm and the flow of meditation track, which is the long range dependencies. Then by LSTM layer, it helps us to analyze the temporal sequences of the audio, and it will help the AI to segregate the different types of audio stem from a audio signal. And last one, we are going to have an optimization process so that we can maintain the quality of the music without with having a lossless quality instrumental output. So this is
Ma'am, you have just 1 more minute left.
okay, okay ma'am, okay, thank you. Okay, so this is the visualization of my work. That is, this is the original song, and this is the vocals, and this is the instrumental part. We just uses one devotional music, that is Sri Ganesh Dhimai, and we did this type of segregation with visual representation. Then this is, we are planning to have a system design where the user can upload the track, which one he or she want to segregate the audio stem. This is the part of user interface. Then at the back end, we have the vocal removal part, where after receiving the track, it automatically pre-processed and put it into the AI structure so that the instrumental part can easily segregate it, and the user can download his or her own choice from the various instrumental part. And there is also a feedback scheme where we can actually update the choices of the person. And this actually the detail, and in the conclusion I can say that this the system actually not only provides scalable method for generating instrumental music on demand, but also open avenues for integrating biofeedback mechanism and personalize in future wellness oriented audio applications. So our objective is to make a segregation of audio segment that actually
Yeah.
gives,
Hello.
yes, well-being.
Yeah. Please
Yes, sir.
conclude your PPT. What is the conclusion behind it? And
This is the
number of SDG goals we are just targeting. So, which goal you have targeted during the
oh,
study?
actually, sir, we have targeted the a clinical approach, therapeutic approach for where for a
Okay.
human.
Okay, fine. But I am just asking about SDG, Sustainable Development Goal. You heard
Okay.
about it?
No, sir, no idea, sir. Could you please make a brief
Oh,
so that?
SDG, yeah, yeah.
Just
Sir,
conclude
I
it.
beg to comment in the mid. I am a supervisor. We have joined towards, right? So,
Okay.
sir, yeah, yeah, sustainability development goal. But sir, when we started it, this 15-point goal didn't there. So in the research proposal, actually, it didn't incorporate. We are exploring with it. Kapil sir.
Okay. So number of goals you heard about it? 1 to 17 goals.
Okay, sir.
Zero hunger.
Yeah, 17, 17. Yeah,
Got it. So please conclude
yeah.
it. And what are the basic? What are the findings?
Oh, sir, till now we have just started working, and it is very in the novice state, I can say. I have just started with the segregating, and though nothing has done with the system design. Only this part we have reached, that we are now going to segregate, and in future we are trying to make the feedback and all to make a system like this.
Thank you so much, Ms. Paromita Das, for your insightful and well articulated presentations.
Yeah, no further questions. So we can go ahead with the next presentation.
I would now like to invite our next presenter for the day, presenting the paper titled Enhancing OCR Accuracy on Degraded Documents Using Hybrid Deep Learning and Classical Filtering Techniques under the code 218. I request Ms. Dimpy Singh to kindly take the virtual stage and begin their presentation. Over to you, ma'am.
Good afternoon to all. I am Dimpi Singh and along with my co-author Shalini Puri from Manipal University, Jaipur. I am presenting our work titled Enhancing OCR Accuracy on Degraded Documents Using Hybrid Deep Learning and Classical Filtering Techniques. Our research focuses on improving OCR performance on degraded handwritten signatures using light-weighted hybrid approach. So basically, the OCR systems perform well on clean printed text. However, they struggle significantly when documents are degraded. So in handwritten signatures, especially issues such as ink fading, smudging, uneven stroke thickness, and background noise make recognition a little difficult. So the traditional OCR engines fail because they are sensitive to noise and distortions. To solve these problems, we propose a lightweight enhanced OCR framework that combines the classical filtering techniques, connected component analysis, a convolutional autoencoder, and a tesseract OCR. Our enhanced autoencoder significantly improves document readability and boosts OCR performance. The proposed model is called EOCR FCCT. It is enhancing the OCR models. It integrates classical filtering, connected component analysis.
May I request presenter to please present the PPT in full screen mode? And can you please remove that side panel so that we can read the entire PPT over here?
Is it
Just
clear,
press
ma'am?
F5 with your presentation.
Is it okay, ma'am, now? I'll reshare the PPT, ma'am. Nice memory. Is it visible, ma'am, now?
See, your slide is visible, but I just wanted it to be in a full screen mode.
Okay, yeah, sure, ma'am.
Thank you.
Thank you, ma'am. So the proposed model is EOCR FCCT. It will integrate classical filtering, connected component analysis, a multi-scale CNN encoder and autoencoder, and a tesseract OCR via PyTesseract. We evaluated our model using a SEDAR handwritten signature dataset from University of Buffalo. The dataset contains 55 different signatures of signers, 1,320 genuine signatures, 1,324 signatures, and each image at 300 dpi grayscale. This data allows us to rigorously test OCR performance on degraded signatures. For training and testing, for evaluation, we used 80% of the images for training and 20% for testing. Both the sets contains 50% genuine and 50% of forged signatures. The system using Python and PyTesseract to measure how much document enhancement improves OCR text recognition was implemented. The proposed methodology algorithm of EOCR FCCT model is we acquire the noisy input image, then the image is normalized and denoised using classical filtering techniques. Connected component analysis removes unwanted noise. The cleaned image is passed to the encoder, which compresses the image features using convolutional layers. In the latent space, multi-scale stroke representations are learned. The decoder reconstructs an enhanced version of the image. A sigmoid activation normalizes the output image. Finally, the tesseract OCR extracts the text from the enhanced image. We then compare these OCR output with ground truth and compute accuracy, precision, recall, and F1 score. This is the proposed architecture of CAE. This slide shows the architecture of our convolutional and autoencoder. The encoder consists of multiple Convo 2D layers that extract and compress features. The latent space captures important strokes, patterns of signatures. The decoder reconstructs the cleaned image from compressed features. Skip connections help preserve spatial information and improve reconstruction quality. Finally, a convolutional 2D layer with sigmoid activation produces the enhanced grayscale image. This lightweight architecture is designed to perform well even in low resource scenarios. These are the experimental results. This is the figure 2. Figure 2 shows the results for the
Ma'am,
sample.
2 more minutes are left.
Okay, ma'am. The baseline filtering techniques with proposed enhanced autoencoder filter were compared. The baseline methods includes denoising, sharpening, Sobel, and Robert, Laplacian, and histogram equalization. Visually, it is observed that the traditional filters either remove useful stroke information or fragment the characters. This is the comparison. The figure shows the OCR character counts after applying the different filters, and we observe that degraded images sometimes produced incorrect or excessive characters due to noise. This is the OCR text length comparison. The degraded image shows high text length because noise is misinterpreted as characters. Sobel and Robert filters significantly reduce text length due to edge loss and fragmentation, and our enhanced autoencoder maintains balance and accurates the text extraction. The OCR performance evaluation the enhanced autoencoder achieved 82% of accuracy, 85% of precision, 80% recall, and 82% of F1 score. So compared to conventional filtering methods, CNN EAE model clearly outperforms them. The conclusion, this is the comparison of OCR performance result, and the conclusion and future work is that we proposed a lightweight hybrid EOCR FCCT model combining classical filtering and CNN-based autoencoder enhancement. While conventional features showed limited improvement, the CNN AE significantly improved OCR performance. This demonstrates that even in low resource scenarios, deep learning-based restoration methods outperform traditional techniques. So for the future work, we aim to scale training with larger data set, develop adaptive hybrid pipelines, explore end-to-end fine-tuning to modern transformer-based OCR models. And this could further enhance the text recognition accuracy. Thank you. These are the references.
Thank you so much, Ms. Dimpy Singh, for your insightful and well-articulated presentation. We are open to questions now.
Yeah, Ms. Tempe, can you go to your initial few slides where you are showing your data set? Just a minute. Yeah, here only.
Yes,
No, the previous one. So don't you think that your data set is too small for conducting this research when you are having tesseract OCR and that too you are using with a character level extraction performance?
Yes, ma'am. This data set this research was performed on a smaller data set only.
So I guess that to get the better result, you should have at least a detail of around like 500 plus different person, and obviously then your this post images and each sign will also get increased.
Yes,
And the
ma'am.
sample image resolution that you are keeping of 300 dpi, that is also too low.
Yes, ma'am. That I'll surely keep in mind in future research, and
Yeah.
will, yeah.
Okay. So that's all from my end.
Thank
We
you,
can
ma'am.
go ahead with the next presentation.
Thank you, ma'am.
I would now like to invite our next presenter, presenting the paper titled Automated Singer Identification Using Deep Learning for Personalized Music Therapy under the code 221. I request Ms. Paromita Das to kindly take the virtual stage and begin their presentation. Over to you.
Okay, thank you, man. Okay, so good afternoon, one and all present here. I am again back with my another paper, that is automated singer identification using deep learning for personalized music therapy. My paper ID is 221 and I am working under the guidance of Dr. Shomshubra Gupta and Dr. Vishwarup Niyogi. So whenever we listen to the voice of our favorite singer, the music increases blood flow to the areas of the brain responsible for producing and controlling emotion. So here I am going to propose a system that with the help of which we can segregate the audio part and the instrumental part of a particular song, and we use that audio part, only the vocal part, for the emotional well-being and the therapeutic cause. So next is some literature review. So this type of model, lot many works are there on this. That is, they are started mainly. We are going to have a voice biomarks in AI. That is introduced in 2025, where they have used the bi-LSTMs and transformer to isolate the vocal fingerprint. That is the main part of the vocal fingerprint, that to identify a vocal traits, that is the timbre and vibrato. Then there are lot many source separation breakthroughs, that's splitter V2, with the help of which we can easily segregate. But my research is there are some research gap, that all of these initiative are concentrating on identifying the singer voice. Okay, but my research contribution is actually, I want to fill the research gap by producing a deep learning framework which can help to identify our favorite vocalist and to use that in our therapeutic purpose. So again, I am using my own data set, which is not a very large data set. Actually, I have started. So I have chosen one of the singers, different song. Then another singer, different types of song. Likewise, I have made my own database. And the characteristics that we are considering mainly, actually all the characteristics mainly depends on the vocal size of the vocal cord, then the what I can the thickness of the vocal cord. So the characteristics that we are going to consider is pitch, then vibrato, format, and harmonic spectral envelope. Above all, the tremble spectral features are also taking a main part in the innovation. So this is my model architecture. It's a very simple architecture. First, from a particular song, we need to identify the features. The features, as I already said, those are formants, vibrato, then different timbral features, which actually deciding upon the characteristics of a person's vocal cords. Then after the feature extraction, the same thing, we are going to use a classifier known as random forest classification. And with those traits, actually, we are going to train the different trees of the forest. And we will find out the maximum probabilities. And then with that set of training data, then the testing will start. That reference template for each singer, the testing start, then we have the recognition part. And these are the, as I was saying, these are the main parts of a vocalist. That formats, which is the vocal tract characteristics resonance. Then vibrato. Vibrato is actually what we can say the voice modulation of a particular singer. Then we have harmonic spectral envelope, which determines the richness of our voice, the different types of different type of attributes of our voice. The last one, which is more important, that is the different timbre features, which depends upon our size, shape, and thickness. And here are some of my outputs. Lot many outputs are there, but here I have used only 3. These are the main parts of timbre. Next, we have the dimensionality reduction technique using PCA, and we find out the maximum number of votes across all trees. Then there the probabilistic interpretation.
Ma'am, 2 more minutes are left.
Okay. Each tree learns different acoustic discriminative patterns, as I already said. Then bagging ensure robustness to recording, variability and noise. Then random feature selection allows some trees to specialize form and structure, others in rhythmic and spectral clues. The ensemble decision forms a complex nonlinear boundary capable of separating singers even under style or channel variation. Then my result, I had some result, but unfortunately, as I already declared that my data set is very less, so the accuracy is not coming properly. Though it is identifying that I have trained the model with 5 singers of minimum 5 to 6 songs, and the model is actually identifying the singer, but the accuracy is less than 20%. So that's why, so this result and discussion part, I can say I will try to include more and more data so that it can provide us a meaningful result with proper accuracy. And in the conclusion, I can say by automating the selection of familiar vocalist, this system transforms music therapy from generic activity into precise, scalable, and data-driven medical intervention. And these are some references.
Thank you so much, Ms. Parabhuta Das, ma'am, for
Yes.
your insightful and well articulated presentation. We are open to questions now.
Yeah, no question for this. We can proceed for the next presentation.
Okay. Thank you, ma'am.
Thanks.
I would now like to invite our next presenter, presenting the paper titled Climate Oriented Responsive Precision, Agriculture and Smart Farming Corpus under the code 222. I request Mr. Partha Kole to kindly take the virtual stage and begin their presentation. Over to you, sir.
Okay. Good afternoon, everyone.
Yeah, you can please continue.
Okay, ma'am.
This is your paper ID 308, right?
My paper ID is 222.
Okay, 22. Okay.
Okay,
Yeah, please
ma'am.
continue.
Okay, ma'am. My paper ID is 308. Hello.
Yeah, you can please continue with the paper code 222.
222. Okay. Thank you, ma'am. This is my project of climate-oriented, responsive, precision agriculture and smart farming. My paper ID is 222. I am Partha Kole, and I create this project guidance of Professor Somsubra Gupta. This the in current era, the agriculture have some face some problem, means the increasing the population of India and the mitigating the agriculture land. The problem is scarcity of foods, so we face the agriculture face the climate and soil changes. Traditional crop selection method is uncertain and needed data driven smart farming for in future. So I create this project. This problem, the soil degradation and insufficient crop selection method, and our India have 60% plus land for agriculture, and we have 1.3 billion plus population in India for feeding. And I also belong to a agriculture family and farming family, so I very much aware of this. This is my proposed system. The data collection method, we use NPK sensors and weather sensors for the use for data collection, and the data pre-processing we use cleaning process, normalization and imputation and outlier removal process. Then we use feature selection method, some machine learning algorithm like KNN, SVM, NetBias, logistic regression, decision tree, random forest, and also artificial neural network. And then we evaluate our accuracy. So this is my data set: the nitrogen, potassium, phosphorus, temperature, humidity, pH level, rainfall, and the crop name also. the pre-processing method, we use some statistical method. For outlier removal, we use I-square and J-square. For feature encoding and normalization, we use label encoder method. This all my machine learning algorithm use this project. K nearest neighbor method, decision tree, random forest, naive Bayes, support vector machine, and artificial neural network. These are my evolution metrics. So accuracy score, confusion matrix, precision recall, F1 score, and cross validation for K-fold method. Those are my findings, result and discussions. The KNN method, we find 98% accuracy. Those are my crops name, and those are individual accuracy. And my average accuracy is 98% for KNN method. For logistic regression method, we find 95% accuracy, and naive Bayes method, we find 99% accuracy. Decision tree method, we find 98% accuracy, and we use ensemble learning like random forest for combine multiple weak learner of decision tree and create a random forest method. This 99.5% accuracy with this method, random forest method. And SVM method, we find 98% accuracy, and this is my artificial neural network accuracy for 500 epochs, 98% accuracy. And result and discussion, as we know, the random forest show the base performance. So we use random forest method for deploying part. For deploying, we use this in a mobile app application. This mobile app application. This is my mobile app application. And if we enter the data, we can find the perfect crop for this climate. This is my mobile app application. Thank you. Ma'am, any question? Sir, any questions? Hello?
Thank you so much, Mr. Prathak Ode, for your insightful and well-articulated presentation. We are open to questions now.
Yeah, we can proceed for the next presentation, right? As such, no question from all three of sessions.
Ma'am, actually, the final presenter is not with us right now, and there is
Okay.
one more presenter who is Rohit sir, but he is not in our session. He's saying that he has confirmed it from sir.
So shall we take that paper?
Ma'am, I'm asking from the organizing committee. Just a minute.
Okay. No problem. Otherwise, we can take it, right?
Sure, ma'am. Sure. Ma'am.
Okay, Mr. Rohit, you can now present your paper, please.
Okay.
Moderators are requested to please make a note of his presentation, because one of the requirement for the further publication process is a presentation in this conference. Okay. So please make a proper note of all title and everything that is now going to be shared by Mr. Rohit.
Sure, ma'am.
So my screen is visible to you?
Yes, sir.
Okay. So myself, Rohit Prajapati. Today I will present my paper on feature selection technique for the resource estimation on the cloud workload. So today I will discuss about all these highlights topic. So actually, feature selection it is very useful to reduce the dimensionality of the data set. As the cloud data set contains the data into the big size and to the high dimensionality. So for this data set, many of the features are not important for the resource estimation, anomaly detection, and the resource management for the machine learning model estimation. So feature selection technique can help us to reduce the dimensionality and to focus on the main features, so which can help us to increase the accuracy and the performance of the machine learning model. So in classification and the regression in both model, the feature selection can help us to reduce the training time and to increase the accuracy. So for that benefit, so feature selection technique can help us to focus on the required features. So in past work, many researchers have used randomly the various statistical technique or the machine learning algorithm for the selection of the features, but they are not cross-verified with more techniques to confirm. So which features can be more informative for the machine learning model. So here I have applied in my work so many techniques with the machine learning model to confirm. So these features have the more information about the target variable or for the specific prediction into the cloud resource estimation. So for this work, I use the data set from the GWA Bitbrain data center. Actually, this data center contains the workload from the virtual machine performance matrix. And this data set contains these features. And from these features, I have to select those features, so which can be informative for the machine learning model. In data processing, so actually I try to convert the data set into the a suitable format, so which can be useful to find out the specific meaningful features from that. So first I find out the missing data. So in missing data, so for the imputation, so actually first I try to know the distribution of the data set, and most of the features found with the positive skew. So for those features, so which have the missing entry less than 10% of the total data size, I have used the mean imputation, and those entry, so which was above the 30% of the total data size, I have used the KNN imputation. And here we can see the one of the feature is presented with the positive skewness to confirm. In data processing, again, I try to filter the noisy data to smooth the noisy data. Actually, I use the three techniques: Z-score, IQR, and the moving average method. So we can see the result of these three methods. Actually, Z-score method can be useful so when the data is normally distributed, but here the all the features are the positive skew, so this cannot be effective here. IQR normally can be useful so when there is extreme high or the low for the outlier. So and also it is the preferable so when the data is not time series, but here the data is a time series, so we have not preferred the IQR. Moving average method, so which focus on the short fluctuation with the frequent changes about the trend, and that is suitable with the time series data and with the with this type of the workload like the cloud or the stock analysis. So here you can see there are very less noisy data point that we can see into the moving average method. Thereafter, so we try to smooth this noisy data, and that we have handled with the help of the weighting moving average method, so through which we can maintain the trend by removing the noise. In data transformation, so we just perform this scaling to bring all the features into the one unit, which can help us to find out the meaningful feature for the resource estimation in cloud workload. So in my methodology, actually feature selection technique mainly fall into the three categories: filter method, wrapper method, and the embedded method. So first I apply the filter method. Actually filter method find out the important subset of the features based on the statistical property of the data. So first I use the correlation coefficient So this technique actually find out the relationship between all the independent variable of the data set and the target variable. So here we can see the result in this table. So after evaluating this technique on this data set, I find out these two attributes features with this meaningful information. So one is the disk write percentage and second is the network receive percentage. Then second method I have used from the filter method, that is the mutual information. In this technique also we got the same two features, so which have the high mutual information score, so from high to low. So the features having the high score, so indicate these features are the more informative, so they can have the more information about the target variable. And this kind percentage also has the high MI score, so which indicates it also has the more information about the target variable. In these two
Sir,
techniques,
2 more minutes are left.
okay. In a wrapper method, I use the RFE method, recursive feature elimination, to find out the meaningful features. Here actually I get the three features: describe, network residual, network transmitted. But these last two features have the multi-collinearity. So I have select only one of them, network residual, and I have eliminated the last feature. In embedded method, actually this method use the machine learning model to find out the meaningful subset of the feature. In this method, I use the lasso regression, so which during the training time, it will determine the best feature, so which can have the more accuracy for the model. So in this technique also I use these two features, so that we were getting into the earlier technique. And then finally, to confirm, so whether these features can help to increase the accuracy of the model. Then finally, I use the XGBoost model with these two features, and then I get the 72% accuracy, so with the minimum model error. So in conclusion, we can say that so feature selection technique can help to reduce the dimensionality and to increase the model accuracy and the performance. Okay, any questions, sir?
Thank you so much, Mr. Rohit Pratap.
Yeah, what are the basic criteria?
Yes, sir.
Evaluation criteria. Can you elaborate all those points?
Evaluation criteria, so here not actually in XGBoost we can set some hyperparameter, but with other
Can you
techniques,
elaborate all those points? Evaluation criteria.
evaluation criteria. So just only this score. If suppose for the mutual information, we can consider the MI score. For the correlation coefficient, we can find out the correlation.
Mr. Rohit, are you
Yes.
available here?
Yes, yes.
Okay, so one of our session chair is asking about your evaluation criteria, evaluation parameters. So can
So
you please justify? Can you please answer the question?
yes, ma'am, I can answer.
Yeah, please proceed.
So in evaluation criteria, actually, so in all these techniques, so those attributes, so which have the good score of this specific technique based on the statistical technique or the machine learning algorithm, so we can more weight on this attribute, so as the feature selection into the machine learning model. Hello, yes, ma'am. Hello.
Okay, no further question. Thank you.
Okay, thank you.
With that, we conclude today's paper presentation session at UNI-TEAS 2026. We sincerely thank all our presenters for their valuable contributions and our audience for their active participation. A special thanks to our session chairs for guiding the discussions with clarity and depth. I would now request all the participants present to kindly switch on their cameras as we can take a virtual photograph to capture this memorable session.
Miss Sweetie, can you please ask Rohit to stop the presentation?
Yes, sure, ma'am.
Thanks.
Yes, ma'am. He has already done that. All of you kindly open your camera. Paramita ma'am, Rohit sir, Parth sir, Subra sir, please turn on your cameras. Thank you all. And okay, let open.
So any other presentation left?
No, ma'am.
Okay, great.
Thank you all, and we now look forward to seeing you.
Shikha ma'am, Kapil sir,
Thank
I'm
you.
afraid to say that I
Thanks.
have to leave for my preoccupation. Can you kindly allow?
Yeah, please. Please, sir.
So kind of you, so kind of. Sweetie ma'am, thank you.
Thank you, all of you.
Shall we leave this session now?
Yes, ma'am.
Okay,
Yes.
thank you.
Thank
Thanks,
you so much,
everyone.
ma'am.
Wish you all the best. Thank you, sir.